Today we're going to explore standard deviation a little bit further. So for the warm-up, we should be able to do this from what we learned yesterday. The two math classes below have the same mean, or the average on the last test, but not the same scores. We use the standard deviation to show variation in those scores. So in other words, how spread out are the scores? Are they consistent or less spread out, or are they not consistent, more spread out? So here are the five scores from Class A, the average, and the standard deviation, and then five scores from Class B, the average, and the standard deviation. Notice they have the same average, class average, but they have a different standard deviation. What do these standard deviations tell us as we compare the two classes' scores? So what we learned is that the smaller the standard deviation, the smaller the average is, the average distance of each score is from the average. So what that means is that Class A has a smaller standard deviation. It means their scores are closer together or more consistent. Class B has a higher standard deviation. These scores are more spread out from the average, so they're less consistent, more spread out. So let's write that down. Class A, more consistent. Which means less spread out. And then we have Class B, less consistent. They're more spread out. So what you'll need to know is that a standard deviation indicates how consistent are you. Are your scores pretty much the same or closer together, or are they further apart? And that number is the average distance of each data point from the average. All right, let's say we add a Class C. Let's find the average for Class C. So remember to find the mean a few ways. Add them all up, divide by how many there are. The shortcut on a calculator is you can add a list and spreadsheet. Name your list. I'll call this data C. Don't put anything in the equals row, and we'll type them in. And you should expect that this has a smaller standard deviation than either of these two. Looks like the average probably is about the same. So 77, 76, 76, 76, 75. Go to an open cell. It's the menu 411. Okay, here's our list. And then here's the average. You can see the average is 76. I would expect the standard deviation to be really low because they're all about the same. And here's our standard deviation, 0.6. So on average, each of these scores are about 0.6 away from the average. So the smallest standard deviation, the least spread out. So the average, 76. And the standard deviation is going to be less than the Class A because they're less spread out. Remember, with standard deviation, I'll make this bigger. The smaller the standard deviation, the less spread out the data is. The larger the standard deviation, the more spread out the data is. All right, so today we're going to look at, well, what happens when you change all the data values in a set? What happens to the standard deviation? What happens to the average? All right, so we're going to make friends with standard deviation. So in your group, let's make up a set of 5 numbers, any 5 numbers that are different. Okay, so each of you will make up 5 numbers, any 5 numbers. So I'll choose 5, 10, 14, 19, 71. All right, let's find the average and the standard deviation of our set. And again, to do that on the calculator, you can open a new list and spreadsheet. Whoops, this is not my calculator. So go home, new document, don't save, add a list and spreadsheet. Name your list, so I'll just call this L for list. And put in your numbers. Put them in any order, 14, 71. All right, go to an empty cell. It's the menu 411. And then find your list. I called it L. Okay, so for my set of data, and yours will be different if you have different numbers, you're going to write down your average and your standard deviation. So my average is 23.4. And my standard deviation is 24 because that's 71. 24.137, I believe. 79. Okay, So now on the next page, okay, let's see or explore what happens to the average and the standard deviation when you add the same number to each member in the set. So I'm going to add any number except 0. I'll add 2. So I'm going to take these numbers, I'm going to add 2 to each of these numbers. So 5 plus 2 is 7. 10 plus 2 is 12. 14 plus 2 is 16. 19 plus 2 is 21. And 71 plus 2 is 73. All right, so whatever your numbers are, pick another number and add that same number to your set. And now find the new average and standard deviation. Okay, so let's go to the calculator. You can actually just type it in right over your numbers, and I think this adjusts. So 7, 12, 16, 21, 73. All right, so now let's write down our new average, and I would expect my average to go up. It does. But then we look at the standard deviation, and I added my numbers right. It is still about the same. It should be exactly the same, though. What did I do wrong? So 7. 7, 12, 16, 21. Oh, okay. Well, we'll say it's pretty close. All right, so let's write that down. Our average did get higher because our numbers went higher. Okay, so my new average is 25 point, I forgot already, 25.8. Back and forth here. 25.8, and the standard deviation is still about the same, 24. Maybe I should have just rounded that to 24, so 24. All right, explain why the average changes, and since our numbers are higher, our average is higher. Numbers are higher. And that means your average will be higher. Okay, but our standard deviation remain the same when we add the same number because there's still the same distance between the numbers. So there's still the same distance between the numbers. If there's that same distance there, the average distance from the average will not change. Okay, well, what about if we multiply the same number to each set? So again, we're going to go back to our original set, and I'm just going to multiply each of those numbers by 2. Okay, and write those down. Okay, so 5 times 2 is 10. 10 times 2 is 20. 14 times 2 is 28. 19 times 2 is 38. 71 times 2, 142. Okay, so let's put those in. And I keep wanting to open that, huh? Okay, so now I'll type these in 10, 20, 28, 38, 142. Okay, so now if you look, our standard deviation much bigger, our average much bigger. And then if we think about how much bigger the standard deviation is, well, if we double the distances between all those numbers, then our standard deviation will also double because those distances are doubling. So let's write that down. Our average is bigger. In fact, is it double? Let's see. So our first average, go back to the original set. Our first average was 23.4. And if we double that, do we get about 47.6? And I would say yes, that is pretty close to double. So our average doubles and our standard deviation will double as well. So let's write that down. Okay, so first I'll write the numbers 47.6. And 48. All right, explain why the mean changes when you multiply that same number to each set. Well, our average doubles because we doubled all the numbers. And then the standard deviation will also double because the distance between each of our numbers doubles. So doubles because the distance doubles. Okay, so let's summarize what we should have learned today. When I add a number to each data value in my set, the average, the mean, stays the same. The standard deviation, when you add the same number, the average doesn't stay the same. That's wrong. All right, so the average will increase, but the standard deviation, since the distance between each of those numbers stays the same, the standard deviation stays the same. How about when you multiply a number, all right, then the average multiplies by that number. And I would argue so does the standard deviation. So I doubled every number, and then the standard deviation doubled as well. So maybe I should try tripling to see if that works. So I'm going to try one more time, but let's triple the original numbers. So again, my original numbers were here. Let's try tripling each of these and seeing so we know that the average will triple. Does the standard deviation also triple? So 15, 30, let's do 14 times 3, 42, 19 times 3, 57, 71 times 3, 213. Okay, so let's check this. I still type at my, okay, so I have 15, 30, 42, 57, 213. Okay, so we should expect that the average tripled. And the first average, oh, there it is, 23.4. 23.4 times 3 is about 70.2. Yep, okay, so that's tripled. How about the standard deviation? Did it triple? Okay, so our standard deviation, this one. Okay, so our first one was 24.1379 times 3. And yep, it does also triple. All right, so we need to edit this right here. When I multiply the average and the standard deviation, SD, they are multiplied by that number as well. Okay, so you can practice this idea with the day 6 daily practice.